In a three-way switch circuit, both travelers are considered current-carrying conductors. This principle is crucial for understanding derating requirements in electrical installations. Even though only one traveler wire carries current at any given moment, the electrical code recognizes that both wires are integral to the circuit's operation and will alternately conduct current. The reason behind this classification lies in the alternating nature of the current flow between the two traveler conductors. Electricity doesn't continuously flow through a single traveler. Instead, depending on the switch positions, the current path switches from one traveler to the other. Each traveler, therefore, carries current for a portion of the operational cycle of the lighting or appliance connected to the circuit. Because each traveler conductor carries current at different times, each one must be rated to carry the full load of the circuit. This is a code requirement and is important for safety. Derating is a crucial concept in electrical wiring. It refers to reducing the maximum allowable current a conductor can safely carry. Several factors necessitate derating, including ambient temperature, the number of current-carrying conductors bundled together in a raceway cable or directly buried in the earth, and voltage drop considerations. When conductors are bundled together, the heat generated by each conductor can raise the overall temperature within the bundle. This increased temperature reduces the ability of the conductors to dissipate heat effectively, potentially leading to overheating, insulation damage, and even fire hazards. The National Electrical Code, or NEC, provides guidelines and tables for derating conductors under various conditions. These tables specify the percentage reduction in ampacity based on the number of current-carrying conductors in a raceway or cable. For instance, NEC Table 310.15 B3 provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable or earth. These adjustment factors ensure that the conductors operate within their safe temperature limits, preventing overheating and potential hazard. The specific derating requirements for traveler conductors are addressed within the context of the overall number of current-carrying conductors in a raceway or a cable. Since both travelers are considered current-carrying, they must be included in the count when determining the applicable derating factor from the NEC tables. Let's consider a scenario involving a three-way switch circuit with 2 traveler conductors, a neutral conductor, and a hot conductor all bundled together in a conduit. In this case, there would be 4 current-carrying conductors, necessitating a derating factor according to the NEC. To illustrate the derating calculation, let's assume the conductors are THHN copper wires with an initial ampacity of 30 amps, as per NEC Table 310.16 based on their size. If there are 4 current-carrying conductors bundled together, the NEC requires applying a derating factor of 80% as per NEC Table 310.15 B3. This means the adjusted ampacity of each conductor would be 30 amps multiplied by 0.80, resulting in 24 amps. Therefore, the circuit's maximum allowable current is reduced to 24 amps to ensure safe operation. If the conductors were THHN copper wires with an initial ampacity of 20 amps and a derating factor of 80% is applied, then the adjusted ampacity of each conductor would be 20 amps multiplied by 0.80, resulting in 16 amps. It's crucial to note that the neutral conductor is generally not considered a current-carrying conductor for derating purposes in standard residential circuits. However, there are exceptions to this rule. If the circuit supplies nonlinear loads, such as electronic ballasts for fluorescent lighting or LED drivers, the neutral conductor can carry harmonic currents. These harmonic currents can cause the neutral conductor to overheat, necessitating its inclusion in the current-carrying conductor count for derating purposes. Voltage drop is another critical consideration in electrical wiring, particularly in long circuits. Voltage drop refers to the reduction in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to malfunction, reduce lighting brightness, and decrease overall system efficiency. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To mitigate voltage drop, it's essential to select conductors with adequate size and conductivity. Larger conductors have lower resistance, reducing voltage drop over long distances. The NEC provides guidance on conductor sizing based on circuit length, load current, and allowable voltage drop. Formulas and online calculators can also assist in determining the appropriate conductor size for specific applications. Properly sizing the overcurrent protection device, such as a circuit breaker or fuse, is paramount to protecting conductors and equipment from overloads and short circuits. The overcurrent protection device should be sized to protect the conductor with the lowest ampacity in the circuit. In the case of derated conductors, the overcurrent protection device should be sized based on the adjusted ampacity value, not the initial ampacity. For example, if a conductor has an initial ampacity of 30 amps but is derated to 24 amps due to bundling, the overcurrent protection device should not exceed 24 amps. Using a larger overcurrent protection device could allow the conductor to overheat and potentially cause a fire hazard. In addition to derating and voltage drop considerations, other factors can influence conductor selection and installation. Ambient temperature plays a significant role in conductor ampacity. Higher ambient temperatures reduce the ability of conductors to dissipate heat, requiring further derating. The NEC provides temperature correction factors to adjust conductor ampacity based on ambient temperature. The type of insulation used on the conductor also affects its ampacity. Different insulation materials have different temperature ratings. Conductors with higher temperature ratings can operate at higher temperatures without degrading, allowing for higher ampacities. The NEC specifies the allowable temperature ratings for various insulation types. Proper termination and splicing techniques are essential for ensuring reliable electrical connections. Loose or corroded connections can create resistance, generating heat and potentially causing a fire hazard. All connections should be made using approved connectors and tools, and all splices should be properly insulated. Regular inspection and maintenance of electrical systems are crucial for identifying and addressing potential problems before they escalate. Over time, connections can loosen, insulation can degrade, and conductors can become damaged. Regular inspections can help identify these issues and allow for timely repairs, ensuring the safety and reliability of the electrical system. When working with electrical systems, it's essential to follow all applicable safety precautions. Always energize circuits before working on them. Use appropriate personal protective equipment such as insulated gloves and eye protection, and never work on electrical systems when wet. If you're not comfortable working with electricity, it's best to hire a qualified electrician. The principles of derating and voltage drop are fundamental to safe and reliable electrical installations. By understanding these concepts and following the guidelines of the NEC, electricians and homeowners can ensure that the electrical systems operate safely and efficiently for years to come. Considering travelers as current carrying conductors plays a role. In summary, firstly, both traveler conductors and a three-way switch circuit are considered current carrying conductors for derating purposes, even though only one carries current at a time. Secondly, derating is necessary when multiple current carrying conductors are bundled together in a raceway or cable, as per NEC guidelines. Thirdly, voltage drop should be considered in long circuits, and conductors should be sized appropriately to minimize voltage drop. Fourthly, overcurrent protection devices should be sized based on the adjusted ampacity of derated conductors to prevent overheating. Fifthly, ambient temperature and insulation type affect conductor ampacity and should be considered during conductor selection. Sixthly, proper termination and splicing techniques are essential for reliable electrical connections. Seventhly, regular inspection and maintenance of electrical systems can identify and address potential problems before they escalate. Eighthly, always follow all applicable safety precautions when working with electrical systems. Ninthly, consult the NEC and other relevant standards for specific requirements and guidelines. Tenthly, if you are not comfortable working with electricity, hire a qualified electrician. Understanding these principles and adhering to the NEC will help ensure the safety and reliability of electrical systems, preventing hazards and ensuring efficient operation. Remember to always prioritize safety and consult with qualified professionals when dealing with electrical work. Ignoring these principles can lead to dangerous situations, including electrical fires, equipment damage, and even personal injury.